This is a tutorial on the Callback Observer for Dragonfly. It is a tool we use when we are working with callbacks and in some situation when there are performance issues. Sometimes callbacks are the main cause of the trouble, and so we need to see who is active, and even sometimes there might be leaks of callbacks, and sometimes it causes some behavior issues. The Callback Observer can be opened from the developer menu. And what we see in this window under the three different tabs are the current callbacks that are installed in the application for object callbacks, class callbacks, and the global callbacks. All these callbacks work similarly inside, but each kind is applicable on different conditions. For example, objects callbacks are installed on instances, objects. Class callbacks are installed for given classes, and global callbacks are installed more globally, no need for objects or class. Let's take, for example, the text presenter associated to the slice index that needs to be refreshed when the view changes the slice. This one is on the view class. For the event name, set camera event, and we are looking at the text presenter for the slice index, this one. Let's open the file where it is defined. It is in text presenter slice index outline in here. This is where this callback has been installed from the class event callback. We call for add callback set camera event. We need to provide the instance of the view, a unique name. In that case, it is defined here, camera callback name with the GUI ID of the text presenter, and the current class name, text presenter slice index. And then we need to provide a function to call when the event is triggered. And this returns an object callback event data that we store in some member variable of some class. And this object has a unique identifier that we can use in some other debugging tools to find, for example, who has a reference on it, or sometimes to know where this object has been defined. We see that this callback, when it is added, is for an event name or as set camera event. The callback ID that is defined in this code here is more a callback name, should be unique, but we should make sure that not to confuse it with the Python ID of the object that is returned. Callback ID here is a string. The Python ID of the object that we obtain is the integer representing the memory location. This callback is seen in the table as to be installed on an instance of view on that object, that instance. It is an instance of view having the title middle view. The event name, set camera event, was defined inside this event callback method. The callback name is what we have set when we install the callback, as you hear. And we see the Python ID of the callback object that is returned to be used for debugging purposes. This table can be sorted by the different columns. For example, we can sort on the GUI ID of the object to gather all callbacks installed for one object in particular. Or we can sort by event name to see what objects are interested to the different events. The callback name that we see can be useful to determine where this callback was created. You can search for the different portions of the text inside the code. Sometimes it will help you to get it immediately. Sometimes it is more complicated to find what is the structure. It is often the case for the text presenters to be cut and the information will be gathered there. It is the case also for other kinds of objects and callbacks. We often see also the value here representing a given instance. And this is to make sure that there will be no collision inside the callback name that we want to install because they should be all unique. You cannot add two callbacks having the same name. It will be forbidden. There will be collision. When we look for the class callbacks, the structure of the information is very similar. The difference with the object callbacks is that we install a class callback on a class. Therefore, we don't have the identity of objects. It is purely on the class. We can look, for example, on the view for a propagate dirty, for example, with this flip and rotate. Flip and rotate property dirty can be searched for in the code. Here, flip and rotate. This is for preferences. Flip and rotate view, property dirty. There are two locations, one to add, one for the cleanup. I'll go for the add. So we see the callback name, and here name ID, started with that, and there is the Python ID associated to self to make sure that it will be unique in that case. And when we add the class callback, we provide the view class name, the callback name, and also the function to call when the event is triggered. In that case, again, following this, the event name is contained here, or as propagate dirty event is what we see as the event name. And similarly, when we go to the global callbacks, we see the event name, callback name, callback ID, callback status, and callback enabled. Let's look, for example, to the display or view mode change. We have this one, or as probe view mode change. Defined here. And in this case, it is for a global callback where we provide only the event or the callback name, sorry, and the function to call. We can see also that these methods can be called for callbacks, where we need to provide again the callback name or callback ID to say if the callback should be enabled or not. And it is because once a callback is installed, we have the possibility to just switch the enabled status so that the callback is triggered or not when the event is received. The application may change that status depending on some conditions. For example, when we select an object or another, this callback enabled status may change. Let's look, for example, in the object callbacks. Bring that back here. Let's say when I change the selection and I refresh my table, some callbacks were created. I will make it sorted by GUI ID. Some callbacks were removed completely, but some callbacks that existed just had a change of property about the enabling of that callback. So this one is false. If I select the Roy and I refresh my table, now this one is enabled. In some situations, you may want to change yourself the enabled status to investigate performance or some behavior that is a bit strange. So you can do that by double-clicking on this cell and changing it yourself. But if you do something with the application that changed that status, then there is not so much you can do. You have to work around it. Let's see, for example, this callback for the text presenter that reacts when the camera changes in that view. Let's say I use the mouse wheel to change my current slice. I see the text presenter reacting with it. This callback is found in the objects callback installed on view for a set camera event for the callback of the slice index, and I will disable this callback. So double clicking, making it at false. Now, if I go here and I change my slice, I see that actually my slice is effectively changed, my view changed location, but the text presenter stays always at the same place because even if the event of the camera is sent and the callback that are enabled receive the function call, those that are not enabled will not receive that information. And so the text presenter is not going to be updated, even if I change it by the mouse wheel, or even if I click on the text presenter, everything else works. If I re-enable the callback, now when I change the slice, everything works properly. So now let's talk about leaks of callbacks. In the case where we change the current selected object by selecting the channel instead of the ROI, and we refresh the table, we can see that some callbacks are created and some others are deleted. I will sort by the callback status to gather them all. All the created are put at the top, all the removed have been put just below, and all the callbacks that were there and are still existing are put below. In some circumstances, callbacks are not properly deleted and they will pile up, and that will be the cause of leaks. And because of that, in some circumstances, there will be too many function call when there will be a single event trigger, and that may decrease performance significantly. So the callback observer might be a good tool to detect what callbacks are in cause, and after that you can look for a way to resolve it. We see in this portion the callback ID or the Python ID of the object callback that is associated to that callback. You can use this Python ID with other debugging tools like the reference finder to see who has a reference on it that may cause the leak. And it may be used also to identify who created it in the case that the callback name might not be sufficient for when you search for it. So you can select that cell, Control C, and you will get this information inside your clipboard. You can paste it in some other debugging tool. You can do the same also on the GUI ID cell, Control C, and use, for example, the object model observer in the filter and paste so that you can see immediately it in the table below and have more information about it. Thank you for watching.